Hello, this is continuation of the last lecture. So in the last lesson we talked about pulley. So then we talked about single fixed pulley, then we talked about single movable pulley. Then we talked about one combination of single fixed and movable pulley. Now I forgot to mention actually the uses of pulley. So in daily life, can you think of something where you have seen the uses of pulley? So actually there are plenty of uses. The best use you can think of it is as a force multiplier. It is generally used as a force multiplier. We'll discuss some more example how we can increase the mechanical advantage of a given system. So actually to lift very heavy load. So suppose you are talking about lift. So somehow your lift is going up. So some pulley system is connected. Then if you see a huge building construction going on and crane is lifting something from one end to another end, the crane actually the whole thing contains a pulley system. Okay, that is called block and tackle system. We'll talk about it. So and even in your car engine, if you see, then there are a lot of rotational motion involved. So you can connect two pulleys. So inside your car there are some systems where one pulley is connected over another by a belt. Okay, so on. So you can see plenty of example in your daily life. Then we talked about I guess 3 examples of pulleys. As I said, now we will move to the next example of combination of pulley. Okay, so this will be my 4th case in which we are going to take one fixed and 3 movable pulleys, and then we'll go to block and tackle system. So in this case, let us draw the diagram first. I have a fixed pulley here, and then one string goes, now you can see this is fixed one and these 3 are movable. So you can sort of imagine that as this is pulled up, the whole system will move up. Okay, now how many strings are used? You can see 1, 2, 3. So here 3 strings are used. So we'll have 3 different tensions. So let us put the tension in place. So I am pulling it by effort E, that will create a tension on my hand. T1, this is acting on my hand. This will act on this pulley. This will act on pulley. The same string, this is T1, T1 and T1. And then if you see, this is the second thing. So on this T2 and on this there will be T2, and this is T2, then in this case this is T3. Now let me just make the clear about the tension symbols. So try to understand, in one string the tension will be same. So 3 string, 3 different tensions. Now see, if you recall the fixed pulley thing, then this is the case. If you recall a movable pulley, then this is the case. Okay, in this is the case of movable pulley. Now try to understand, this T1 and T1 is acting on this. This T1 and T1 is acting on this. If you say where this is acting, actually this T1 is acting on the fixed point. Okay, so we'll consider pulley as our system. So this is the tension acting on this fixed point. These 2 tension are acting on this pulley. Now if you imagine that the system is in equilibrium, you can see that the load will be equal to twice T3 and effort is equal to T1. By applying effort we create tension. Now what will be mechanical advantage? Mechanical advantage is load by effort. So load is twice T3 and this is T1. Now this is our mechanical advantage, but you can see we are not getting any number like 2, 3, 4, T3 by T1 we don't know. This can be easily find it out. We can find it out. So if you pay attention, you can see this T1, this 2 T1 is balanced by T2. So twice T1 is balanced by T2. Okay, this I am talking about this and this. Now if you pay attention, twice T2 will be balanced by T3. So twice T2 is balanced by T3. Now if we see this, then I can write T3 equal to twice T2 from here only, same thing. Now T2 from here if I substitute, then this will become 2 times twice T1. So this becomes 4T1. So we can see T3 is 4T1. Now if I put this back in mechanical advantage, then mechanical advantage twice T3, T3 is this much, 2 times 4T1 by T1. So 2 4s are 8, T1 get cancelled, so 8, and for one reason we write it's 2 to the power 3. So this is the calculation of mechanical advantage. So if we have 3 movable pulleys, then the mechanical advantage is 2 to the power 3. So if suppose we have n movable pulleys, okay, with one fixed pulley, n movable pulleys, then mechanical advantage will become 2 to the power n for n movable pulleys in this case. Right? Now we have to calculate the second parameter, that is called velocity ratio. So velocity ratio, let us say if you pull this slowly by x, this goes up by y. So distance traveled by effort and is x and distance traveled by load is y. This is my velocity ratio. Again we are not getting any number, so we'll use the principle of ideal machine. Work input is equal to work output. So work input is E times x or T1 times x, and work output is twice T3 times y. Now we just found out that T3 from the last calculation is equal to twice T1, right? So work output, I can write it as 2 times T3 is this. Okay, sorry, one mistake. Okay, I will just see this. Twice T1 is equal to T2, then T2 twice T2 is equal to T3. Sorry, so T3 is 4T1. Okay, that was my mistake. So T3 is 4T1, so work output will become 2 times 4T1, that is 8T1 times y. Now if work output and work input are same, you can see work input is equal to work output. So you will see that T1x is equal to 8T1y. So x is equal to 8y, or y is x by 8. So that means if you pull it this by 8, so if x is 8, then y will go up by 1. Okay, so you have to apply force over larger distance to lift the load by a smaller amount. So just you can see from here, and again if you use this concept in velocity ratio, you will find that the velocity ratio is also 8, that is 2 to the power 3. So if we have n movable pulleys and the system is ideal, then mechanical advantage is 2 to the power 3, and if we velocity ratio is also 2 to the power 3. Now if we have n movable pulleys, then the same thing will become velocity ratio equal to 2 to the power n. As I mentioned earlier, n is the number of movable pulleys, right? So this is one case, one fixed 3 movable pulleys. You guys can do like as your assignment or exercise, like what if only this pulley is there? So one fixed 2 thing movable, you can add one more, one fixed 3 movable, and find out what is the mechanical advantage and velocity ratio. Now we are going to discuss the next example of block and tackle. Now, as I was mentioning you in the application of pulley, that pulley is generally used as force multiplier. So in the last example we just proved that we can increase the mechanical advantage. In the last example we made it 8. That means it will multiply your force by 8 times. Okay, that is the meaning of mechanical advantage of 8. So if you are applying 1 as effort, it will make it 8. Now we are going to move to next example of block and tackle. So this is the 5th thing, block and tackle. Now in block tackle system, let us draw first let us say one diagram. So this 3 pulleys are connected like this, and let us say this is 2 pulleys are connected like this, and there is a load here. Now we take a string and see how it goes. Okay. Now this is one arrangement of block and tackle. Now this is called upper block, this is upper block, this is called lower block. Okay, so you can see the upper block and this is lower block. Upper block contains 3 pulleys and lower block contains 2 pulleys. There is a restriction in the upper block and lower block, and the restriction is like this. Upper block will contain one more pulley or equal. Upper block will contain one more pulley or it will contain equal number of pulleys as lower block. So in this case we can see this upper block contains 3 pulleys and lower block contains 2 pulleys. But you can also make a system where in upper block there are 2 pulleys and lower block there are 2 pulleys. Okay, now this is the only restriction, and it's nothing like we have to take 3 and so on. You can design with different thing. You can take 2 as this and 1 as this and so on. We'll discuss this as our example, and one more we'll discuss like this only, and let's see okay what we obtain in mechanical advantage and so on. Now if I ask you how many ropes are used here, so what will be the answer? So see, this string is going like this, and again so same string is wound up everywhere, so only single string is used, single. So it makes our life easier because tension will be same throughout the string. Now you can see there are 5 pulleys here. This one is bigger, this one is a bit smaller, this one is smaller, and in the lower block this one is smaller, this one is a bigger. So you have to take that into consideration while drawing it. This one will be the biggest, then a bit smaller, then this will be the smallest, then this will be smaller than this. Okay, and then you tie a rope around this. Now in this case, sometimes it is also asked how many strands are used. Strands of tackle. Strands of tackle. So strands means you have to count this. Okay, 1, 2, 3, 4, 5. So in this scenario, 5 strands of tackle are used. Now let us distribute the tension. So I am applying effort which will create tension on my hand. This will not act, this is not acting on the rope or pulley. Then this goes and this load is pulling down, so this tension will be like this, then this will be in this direction, this. Now one way of simply looking at it, just imagine you have 1, 2, 3, 4, 5 rope. Okay, somehow this load is pulling it down, so tension, this tension is actually acting on this pulley. Okay, and that tension will be somehow managed by this string. So this string will develop that much tension which will balance the load, right? So actually these tensions are acting on pulley, and that tension will be somehow transmitted to this string. But as we talked about in the last this in the last thing also, that we in this case we can ignore the tension offered by this. We can just say that these 5 tensions are supporting it. Now if I calculate the mechanical advantage, so first effort is T, and what about load? In equilibrium it will be balanced by 5 strands, 1, 2, 3, 4, 5, and all tensions are same only. So load will be 5T, so mechanical advantage is load by effort 5. So if I have 5 pulleys in block and tackle system, mechanical advantage is 5. What about velocity ratio? So let us say this slowly moves by x and this slowly moves up by y. So work input is equal to work output. Work input is effort times x, that is T times x, and work output is 5T, are taking it up. So 5T times y. So you will find x is equal to 5y. So velocity ratio, which is x by y, will be equal to 5. So you can see in block tackle system, velocity in ideal case, mechanical advantage and velocity ratios are equal to the number of pulleys in the system. So if I take 2 and 2 here, then our number will be 4 and this 4, right? Now this also tells you one more thing, that y is x by 5. That means if you pull this by 5, this will move by 1. So you have to apply effort over a longer distance to move load by a small amount, right? Now let us now talk about what will happen if this block and tackle contains equal number of pulleys. Okay, you guys can easily do it, that one. So this is again block and tackle, but the upper block will contain same pulleys as the number of lower block pulleys. So this is 1, 2, this is upper block, and smaller block or lower block is this. So how you tie the rope around here? This is load, this is effort, and going by the same analogy, tension on this will be all same, let us say T, and you will create effort to create a tension T. Now you can see that in equilibrium load will be balanced by 1, 2, 3, 4, 4T, and effort will be balanced by T. So mechanical advantage of this single system is 4. I am keeping to you how you will calculate the velocity ratio. Prove that the velocity ratio will be equal to 4. Now coming to the ideal system. So in ideal system, mechanical advantage and velocity ratios are same, but when we talk about non-ideal system, like if there is a friction and there is an actual machine, so we talked about it that mechanical advantage will decrease and velocity ratio is not going to change. So in this case, let us just talk about it a bit. So let us generalize block and tackle system. If you have n number of pulleys, then in ideal case mechanical advantage is n and velocity ratio is n. If you have n number of pulleys, right? Now what happens in block and tackle system? You can take n number of pulleys, right? So let us say the load, this one, is balanced by n number of pulleys, and the lower block has mass. Total mass of the lower block is W. Okay, actually we should consider the mass of the upper block also, but so we have, let us say, n number of pulleys. So this load will be balanced by, if you guys can recall, earlier it was balanced by 5T, then it was balanced by 4T. If you have n pulley, then it will be balanced by NT plus weight of the pulley. Now try to understand that previously when the system was ideal, we are not considering the weight of the pulley. This is the weight of the lower block pulley. Okay, now you can see load is this, sorry, this won't be like that. The load is acting in this direction, NT will act like this, W will act down only. Okay, sorry for that. So in this case, if we consider entire lower block having weight W, it will act down along with L, and it will balance by NT. So actually NT is equal to L plus W. W is the weight of the lower block pulley. Now this load will be NT minus weight. T is nothing but the effort, so load is NE minus W. Okay, if you remembered, effort is tension. So mechanical advantage, which is load by effort, load is this much, NE minus W, and this is effort, so we'll get N minus W by E. So you can see that if we consider mass of the lower block only, okay, then the mechanical advantage becomes less than N. N is the ideal limit. But in this case, I talked about in the first example of pulley only, a single fixed pulley, that velocity ratio will not change because the string length is constant. If something goes this much, that will go by that much, that has to be fixed. So velocity ratio will be same. Okay, in this case. Now efficiency is mechanical advantage by velocity ratio. Now since mechanical advantage has decreased, efficiency will decrease. Okay, this is going to remain same. So in case of when we consider the load along with the weight of this pulley, then the efficiency decreases. Okay, right now we prove. Okay, we are going to end with this. In this case, in the next video I am going to solve some questions from your textbook. Thank you.